Just like the protagonist in the film Beauty and the Beast, a rose will play a key role in this next experiment. However, our approach will be totally different. We will decolorize our rose with some chlorine gas. Let's get started. First of all, we will need chlorine gas, which can be produced through the oxidation of hydrochloric acid, using potassium permanganate as an oxidizing agent. In this reaction, the oxidation of the chloride ions in the hydrochloric acid results in the formation of chlorine gas. It is clear from the chemical equation that the initial -1 oxidation number of chlorine becomes 0 by the end of the reaction, meaning that chlorine is oxidized, while manganese is reduced in the reaction. That is, this is an oxidation-reduction reaction. Next, we will immerse the rose into a solvent to dissolve the protective wax layer covering the surface of the petals. The chlorine gas can thus easily penetrate the rose petals. Chlorine gas is highly toxic, so the experiment must be performed in a fume cupboard. With all the equipment set up, and with the potassium permanganate in the flask, we can carefully add the hydrochloric acid to it. As it comes into contact with the yellowish-green chlorine gas, the rose in the glass cylinder soon loses its color. But what lies behind this process? Chemistry gives us the answer to that question as well. Chlorine is well soluble in water, which is present in the petals. The process yields hypochlorous acid and hydrogen chloride. However, when exposed to light, hypochlorous acid decomposes into hydrogen chloride and nascent oxygen. It is nascent oxygen that is responsible for everything, as it is highly reactive and can therefore easily break down substances. It is responsible for the loss of color in our rose, too. It breaks down the organic pigments in the rose petals. First suggested by Ignaz Semmelweis, an early pioneer of antiseptic procedures, disinfecting with a chlorinated lime solution is also based on this principle, as is the cleaning of swimming pool water and wastewater. And last but not least, household bleach obtains its whitening and disinfectant properties from nascent oxygen.